Hey everybody, welcome back. In this video, we're going to finish up 8.3. So I'm calling this 8.3 continued. This is something called an infinite geometric series. It's the final piece we need to finish up our discussion of series. Okay, so I really urge you to watch the other video to kind of warm up, or if you've done all the work leading up to this, you should be fine. So let's get right to work here. All right, so what I've done, I've made you some notes, so you can write this down if you want. You can pause the video, of course, and so I might be going kind of quick to keep up with writing. But all right, so we got 8.3 continued, this infinite geometric series, and they're of this form. This is the generic form. As you can see, it's got a common factor of a everywhere. So the cool thing is you can write this a on the outside of your sum, or you can put it in the sum that's going to do the same thing. What's different here is this infinity symbol on top of these summations. Okay, so I'm going to show you one right here. This is an example of one of them. And in this example, you'll notice R is 3, because you find that by dividing 6 by 2, or 18 by 6, 54 by 18. All of them give you 3. Your first term is 2. Okay, so this is putting the thing to work, showing you kind of how the notation works. Now, this doesn't have a sum. You can't sum this up because this thing gets infinitely large. So you could write equals infinity. Okay, so they wouldn't ask you to sum one up like that. That's just getting used to the notation. And again, it's just notation I put in here. So let's get to work on one that we can sum up. So this is going to require a little bit of explanation here. This series, they say, converges. And it converges means that it has a finite sum. So as we start to add these up, this is getting smaller and smaller. The contributions get smaller and smaller and smaller. So at infinity, that's essentially you're adding a 0 to it. And the reason is, if you look at this formula, and this is a pretty simple one, S is A over 1 minus R. And that's also on your AFM formula sheet that's linked in our homepage. You can see it comes from this formula. And what's happened here, this guy's dropped out. And what happens is that this R is less than 1. That's the condition we need. And that means a proper fraction for in simple terms. Then this thing essentially goes to 0. And you can kind of see that. I've kind of modeled it right here for you. I took something like 1/3, which would be an R, an example of an R. And as it gets large, you can see that it goes to 0, pretty fast. It's not 0, but it's getting really small really fast. See, for n is 5, 6, 7, 8, even by 10, we're getting really small. So that hopefully can kind of convince you that this thing works. Now let's go to work and compute one of these things. So if you're asked to do an infinite sum like this, there's your formula. If it says find the sum and it's got these dots, hopefully they're not going to try to trick us into trying to find one we can't find. So we're looking at this thing, we test it. All right, 2/5 divided by 2, that gives us our R. That gives us 1/5. So R is 1/5, and that is meeting this condition. That does meet the condition. So we're going to say A over 1 minus, let's put R in here. And this is all we would have to do to compute this thing. And we're going to get, what, 2. I'll tell you what, if it was me, and I was you, I would be doing this in the calculator anyway. But I'm just going to show you how the math kind of works here. 4/5, right? Because that's 5/5 minus 1/5. And that's going to be equal to 10/4, which is 5/2. So there's your finite sum. Now, let's take a look at this thing, and I'll show you a trick you could use if you were so inclined. One way to do this, and I've told you can use this calculator for just about everything that you run into with these sums. Okay, so you can sum this up. You say math, choose your sum. You're going to start at 0. And here's the formula you need is coming from what you know about geometric sequences. It's 2. Now you got to be careful. I tried to use that that fraction alpha y equals earlier, and it really didn't work good for me. So I had to do them like this. Just do the 2 divided by 1/5. And now the problem we've got here is we can't put an infinity symbol up here on top of our sum. So we just saw in that table the contributions get really small. So if I even go out to the 100 terms, it might work. And let's see. Yep, there's that 2.5. There's your 5/2. So that's another way to do this. Okay. All right. Another job that comes as a result of doing these is you can express a repeating decimal as a fraction. And I wanted to show you one of these. This is commonly something they put into these units here. And you know what? I'm going to have trouble with that. I can already tell. So I'm going to start a new one. All right, so this would be equal to. Now, that 0.1 in the front there is 1/10. So you would say, well, this is 1/10. And it's going to have this place here is 1/100. So you'd have 1/100. And then you'd go to, oh, that's the wrong one, but it really doesn't matter. And the last one I'm going to do here, and kind of make this video not too long, you'd have 1/1000. And you can kind of see what's happening here. All right, so that would be equal to, well, you could use your a over 1 minus r. What a is 1/10. 1/100 divided by 1/10 is 1/10. So really you have, and you know what, let's use a calculator for it, just to show how quick this can go. This will be a good example. All right, so let's clear that out. So basically I'm going to use this template that I told you about a minute ago. And I said didn't work good in there. And I'm going to put this in there again. So I have a over 1 minus r and it's 1/9. So there's your infinite sum. Again, do the same thing with your formula. I mean by hand, but I just wanted to show you can use the calculator for this. And that's it for this video. This should get you through I think there's an IXL that goes with this. But there's one more piece I want to show you in another video, but it's going to be a quick one. So I'll see you in the next video.